The create task is going to be worth 20% of your final AP score. This video is designed to give you a big picture overview of what that task entails. That way, as you start to get to work on the smaller individual components of it, you have a big picture idea of what it is you're working towards. There are 3 main artifacts you need to create and submit to the College Board to get this task done. The most important of which is the program code you're going to need to write to develop an original program that solves some problem. If you have well planned out and well executed code, that's going to do the rest of the work for the other parts for you. The next part's the written response. These are going to be 4 questions about your code. It's going to be things about its purpose and how the mechanics of specific segments in your code work. Finally, you're going to make a short, no more than 1-minute video, just as a way to show whoever's grading your project what your code does, and in a way provide proof that it works. Because the program's the most important, we're going to spend the most time on that here. Specifically, we're going to talk about all the things that program is required to have. The first thing is that the program needs to work using inputs and outputs. Specifically, it needs to be able to take in data from an outside source, maybe something like user input or loading up a file, and that data that's taken in as an input needs to shape whatever output it reports back to the user or back to the computer, depending on its purpose. The data in your program at some point needs to be stored in a list in a way that helps manage the complexity of the overall program and makes it easier to develop and even edit and debug. And finally, somewhere in your program, there needs to be a complex process that you abstract into a procedure or function. Something that takes in different inputs and gives you a different output as a result, almost a smaller program within your main program. For the inputs and outputs, just to be a little more specific about it, an input is an outside piece of data sent into your computer. The most common way students solve this problem is with user events, things like clicks, button presses, text entries, or things along those lines. But according to the requirements, it could also be things like accessing a data stream or loading up a file. Your program should then take that data and process it in some way. It's going to use that data, mix it around maybe with some preset things in the program code, and generate new outputs from the user. This again could be text, this could be sounds, this could be changes in the color or the layout of the program, anything that shows responsiveness to the inputs that were sent in. When you're thinking about these inputs and outputs, you do have to remember these are things that will need to be demonstrated in your video. So make sure there's something visual about it. Next, you need to make sure that your program has a list. A list is just a collection of data that's going to be associated with only a single variable. That way you can handle a bunch of values all at once. You can't just add a list after you're done with your program to meet this requirement, though. You need to be able to show how the list is directly related to your program's main purpose, to the thing you set out to do. And finally, you'll need to be able to justify how this list makes your program easier to develop, maybe in comparison to alternatives like declaring a ton of extra variables, or maybe the list was essential for the program to run in the first place, and there was no way you could write it feasibly without a list. And the function in your program needs to be some chunk of code that contributes to the overall purpose, and is probably going to be repeated more than once. At least twice. The function needs to work using parameters. So when you declare the function, when you write the function, it should take at least 1, if not more, different inputs that will change the way it works. It's going to do this by using not only sequencing, which is the order that the code runs, but selection, which are if statements, basically, that are going to check these parameters and determine if the code should execute certain chunks of it or not. It also needs to utilize iteration, which is most commonly done with loops. So there should be segments of the code that repeat themselves either until some condition is met or maybe for some predetermined amount of time. As proof of this, in your program, your function will need to be called with different arguments, so different inputs for the procedures, and this should cause the function to run differently based on the selection. It might run one chunk of code based on the if statement and another chunk based on an else if, depending on what those parameters were. The written response, if you have solid program code, is easy. because all you're doing is relating the code you wrote to the specific prompt provided by the College Board. There are 4 questions numbered 3A through 3D. The reason it's 3 is just because they count 1 as the program, 2 as the video, and 3 is the written response. 3A is very straightforward. You're just going to describe the purpose, the functionality, and what the inputs and outputs the user will interact with are. Purpose and functionality, just in a nutshell, I like to think of it like a hammer. The purpose of a hammer is to build something, and its specific functionality is to hit nails, drive them into wood, or something like that. You're just going to say the big picture idea of your program, and then some of those specifics about how the user will actually interact with it. The next question is focused in on the list. So you'll need to point out how your list works in the context of your program, and also show how the list was the best choice here, how it managed complexity, again, compared to other variable types, or how it made the program code possible. The third question is specifically focused on the function or the procedure, how it works, and how it works in the big picture context of your program. And finally, the last question is going to focus on how the arguments that you substitute in for those parameters change how the code runs, and how it uses selection to have the same function run in different ways. The rubric is divided up into 6 points. The 6 points are directly tied to questions or the video from the previous slide, from the specific written responses asked by the College Board. The first point in the rubric is tied to making sure your program has a purpose and a function. The grader will determine this based off of your response to 3A, in addition to what they see in the video. The next point is focused on just if you have a list and you use the list legitimately in your program. So that second point is going to be tied to using the list. The third point is tied to you proving that this list manages the complexity, that it was one of the better choices for how to organize the data, and making sure you're not just adding a list for the sake of saying you have one. 3C is looking at making sure you have a procedure or function in your code, and again, that it is legitimate, that it is required for the main purpose of your function. 3C, the second point in the rubric, looks at how the actual function is declared and how selection, sequencing, iteration, how all of that takes place within your function. And finally, 3D looks at how 2 different parameters change the way that code works, how those 2 different parameters will result in the selection having the code operate in different ways. Now that you have the big picture of the project in mind, I wanted to give you some strategies to getting the project done, a potential workflow to make sure you get through the project in an efficient way while still making sure you get all 6 points on the rubric. For this workflow, what I recommend you do is start by picking your topic. So starting with topic selection. This is actually a delicate balance you need to strike when you're picking what you're going to make your app about. You want to pick a topic you like. You want to pick something you find engaging, something that you'll look forward to working on over 2 to 3, if not more weeks than that, depending on how long it takes you to make this app. But at the same time, you want to be careful to not pick something that you fall into a rabbit hole of. For example, let's say you collect shoes. You really like finding the latest and greatest sneakers, maybe weird colors or misprints or something like that. It might seem like a great idea at first to make an app related to it, but if you catch yourself every time you start to work on the project just going off and looking up prices and looking up the latest news instead of getting anything done, that can be a problem. So you need to find a topic that you're willing to work with, but not one that you'll get totally lost in. Once you have the topic in mind and a general purpose, what is your app going to do, you need to make sure you've hit all the technical requirements. So next you want to start thinking about the list and the function that your program is going to need to have. Is there a genuine way, a reasonable reason to store the data in a list, a collection in your app? Is there something where there'll be maybe multiple selections or something that'll take multiple values to figure out? And for the function, is there some complex process that's going to be repeated? Maybe it's the core loop of some game, maybe it's a major calculation based on multiple factors, but you need to make sure that your topic leads to you choosing a list and a function and making sure they exist in your program. This might take some back and forth as you're picking your topic. You might get to the point where you think, do I have a list and a function I have? And if you don't, you're always free to then bounce back to topic selection and then bounce back choosing your list and function. and cycling between those, iterating between them, until you've hit a good balance and you're confident that the topic you chose is going to meet the list and function requirements mentioned earlier in the video. At that point, you can start writing the program at large, and you can start with the development process. Here, you can start doing things like gathering all the assets you need, making sure to keep track of proper citation info for when you use it in your final product, things like the author and the site you might have gotten some images from. And you can start making sure that the list and function that you envisioned actually work in practice. Again, just like with the first two steps, this gives you another small cycle. As you work with the list and the function in your development and see if they can actually be brought into code, you might need to revisit it and rethink what you want for your list and function. And in the worst case, that might mean you have to go back and rethink what your topic is. But hopefully you've picked a solid topic that can use lists and functions well, so once you're confident in that, you can go back into your development process and get that done. Once you have your program developed, and once you have a working demonstration of at least two different parameter cases on your procedure, that's all you need to satisfy the College Board's requirement. So at that point, what you want to do is you're going to want to start doing your writing. And start making sure that all of your writing can address the prompts. That you can cite specific examples in your code that meet what they're asking for, and to make sure you can explain things like how your list manages complexity, and how your function uses sequencing, selection, and iteration. And yet again, if you need to go back and change your code up a little bit so that it does that, and then revisit your writing, it's easier to do that without having to loop back through the entire process. The easiest step at this point, once you're done with pretty much all of this, is to finish up your video. And I'd recommend using something like OBS if you're using a Windows computer or a Mac, I believe, or Screencastify on a Chromebook. It's something where you're just going to use an easy screen-grabbing software to record your screen of the app running, making sure that you're hitting all the points that you mentioned in your writing. After this, you might need to revisit your writing for the first question because you do need to mention what happens in your video. And, worst case scenario, you might have to refilm your video after realizing you didn't cover an important input or output, or some specific program feature you mentioned before in your writing. At this point, you are done. That said, you should probably cycle through things like the rubric, go back to the beginning, go back to checklists that you might have developed on how you're going to accomplish this task, and make sure you have all the pieces. This program and this project is meant to be something hopefully fun and engaging. And if you follow an organized procedure, if you have a plan from the get-go, it can be a really rewarding process. So hopefully this video helped, and if not, there's probably others.